Assalamu alaikum dear students. Today we are going to start chapter 7 long questions. The question is, what is the atmospheric pressure? How it is measured by using a mercury barometer. Also describe how weather changes, what atmospheric pressure. Now first we are going to define our atmospheric pressure definition. The pressure that atmosphere exerts is called atmospheric pressure. The pressure of the air at a given place varies slightly according to the weather. At a sea level, the pressure of the atmosphere on the average is 1.013 multiplied by 10 raised to the power 5 Newton per meter square. Unit is a commonly used of the unit pressure the atmosphere, such as a 1 atm equals to a 1.013 multiplied by 10 raised to the power 5 Pascal. Another unit of a pressure used to a metrology and on the weather maps is a bar, which is defined as 1 bar equals to 1.000 multiplied by 10 raised to the power 5 Pascal. Thus, standard atmospheric pressure is slightly more than 1 bar. The air around us exerts a force in all directions and opposed by an equal pressure inside our body. Thus, we generally unaware of the climbers at high altitude encounter lower atmospheric pressure due to the thinner air. The thinner air causes breathing difficulties due to the lower level of the oxygen. Now we are going to discuss about the measurement of atmospheric pressure. So how can we measure? An instrument that is commonly used the atmospheric pressure is the mercury barometer. Now how we can use a mercury barometer? What's a mercury barometer? Do the construction and working of barometer, we are going to discuss about that. Italian mathematician Evangelista Telesilia 1608 to 1647 invented in 1643. Figure A shows a Telesinian barometer. This is the barometer. Look at this is an upper stage is there is a vacuum, then and lower side there is a mercury, and the air pressure exerts in the downward direction. In this figure that normal atmospheric pressure and the higher atmospheric pressure. Look at the diagram that first one diagram, lower normal atmospheric pressure, the mercury is in the downward. When the atmospheric pressure is going to be increased, the level of the mercury is also increased. Look at the diagram number 2. You clearly see that mercury is going to be a rise up. A long tube that is open at one end and close to the other end is filled with the mercury and they inverted into the dish of mercury. Once the tube is inverted, the mercury does not empty into the bowl. Clear? When we inverted, mercury is not going to be tube is not going to be empty. Means mercury doesn't come into completely into the dish. Means it is in the tube, but when we inverted, instead the atmospheric exerts a pressure on the mercury in the tube is the same height as above the bowl. In this way of the force exerted on the bowl and the mercury of the atmosphere is equal to the weight of the column of the mercury in the tube. Any change in the height h of the column of the mercury means that the atmospheric pressure has changed. At a sea level, the atmosphere will push down on a pool of a mercury and make it rise up in a tube at the height approximately 760 mm. Atmospheric pressure and weather. Barometer kept at the same place at the same height above the sea level shows some variations in the atmospheric pressure from day to day. These pressures varies as shown on a weather map. Means these pressures are not same in all the sides. It's variations. These pressure variations as shown in the weather map. The line of the map joins all those places with the same atmospheric pressure are called the isobars. The unit of the pressure is used in the weather maps is a millibar, and the symbol of the millibar is a m bar as we have written in the bracket. Thousands millibar equals to a 1 bar, means a 1 bar equals to 100 kPa. ठीक है, kilopascal. Usually the range of the atmospheric pressure varies from the very high pressure of 1040 millibar as lower as 950 millibar. Winds move from high pressure regions to the low pressure regions. We know that it's always moved from higher to the lower side. The northern hemisphere, the wind moves anti-clockwise around the areas of the lower pressure and clockwise around the higher pressure. Means that at those places where the pressure is lower, the wind moves in the anti-clockwise, and those areas in where pressure is higher, the wind moves in a clockwise direction. The strength of the wind is determined in the pressure gradients from the weather maps. When the isobars are closely packed together, indicates that a higher pressure gradient. This means that strong wind may result. Now, the next question is, give some applications of the atmospheric pressure in our daily life. Means where we are using this atmospheric pressure in our daily life. So there is a big use of atmospheric pressure in our daily life. First one example is drinking through straw. Means the action of sucking increase the volume of the lungs. Thus, by reducing the air pressure in the lungs and the mouth. The atmospheric pressure acting the surface of the liquid and then greater than the pressure of the mouth, thus forcing the liquid to rise up the straw in the mouth. Look at the diagram of the glass and the straw. We are going to sucking from the straw, and the liquid is going to be a decrease from the glass. Working of the vacuum cleaner. Vacuum cleaner is the normal machine which we are going to use in our homes, and we have seen that a vacuum cleaner. Now the working of the vacuum cleaner, how the vacuum cleaners work. Vacuum cleaner consists of an electric motor with the fans, filter bag and the tube. When the electric motor is switched on, the fan rotates in such a way it sucks the air inside the container and sends it out through exhaust, creating a particle. Look at this one diagram. The pressure air, there is a motor, and look at this one fan. Its fan is in there. There is a front of there is a filter bag, and this one side in the start front mouth is a dirt air. It's captured the dirt air. Vacuum cleaner inside the container. Okay. By doing this, the lower pressure region is created inside the container as materials move from a higher pressure region to the lower pressure regions. Surrounding air moves from outside container wise the tube inside the container, while surrounding air moves inside with the more force. It gather all dirt and dust it comes across in its way, thus pulling them inside the container. Thus, dust and dirt particles are filtered and stored in the filter bag, which will be disposed later. Pulling liquid up in the syringe. To draw liquid in the syringe into the syringe, and shown in the figure, the piston of the syringe is down backward, drawn back upward. This decreases the pressure within the cylinder. Atmospheric pressure acting on the surface of the liquid drives the liquid into the cylinder through the. Look at this one diagram. It's a plugger, and we are going to be sucking from through the container. Now, nozzle of the syringe. Thus, atmospheric pressure helps the fluid to lift up in the cylinder. We are going to look at this. There's a pressure less than atmospheric pressure and the atmospheric pressure. So when we straw the cylinder, the liquid is going to be inside the syringe, so pulling liquid up into the syringe. Now the next one question is define and explain stress, strain and a Young modulus. The wire under the tension will exerted. Its extensions depends on the number of the factors such as the tension and its diameter, length and the material of the wire. Suppose the wire of the length L and cross-sectional area A is stretched by the force F and extension produce is x as shown in the figure below. Look at this one. This is the length. It's a force, area, length, and the extension. So what is the stress? The stress applied to the wire is defined as the force applied per unit area of the cross sectional to produce deformation. Mathematically, the stress is equals to a force by area of cross section. Stress is F by A. The unit of stress is a Newton per meter square or a Pascal. The strain. The result of the wire being stretched into the under the strain. The strain is defined as the extension per unit length. Mathematically, we can write the strain equals to a extension by original length, means E equals to X by L. Since stress is the ratio of the two lengths, it does not have a unit. Young modulus, a strain produced a stretched wire is proportional to the strain within the limit of the proportionality. Within the limit, the ratio is the constant. Those values depends on the material of the wire, as known as a Young modulus of the material. So mathematically, stress is directly proportional to the strain, and stress is equals to a constant into a strain. The constant's proportionality is called a Young modulus, denoted by a y. Stress equals to Young modulus multiplied by strain. Rearranging the above equations, we get Young modulus equals to stress by strain. Young modulus is denoted by y. Putting values of strain and stress, we get y. Young modulus equals to F by A by X by L. So it comes a rearranging that F into L divided by A into X. Stress strain curves. Stress and strain curves are measured by stress testers. Thus, the applied stress is increased, and the change in the length is denoted the value and then the pointed on a graph A typical graph of material as shown in the below. Look at this one graph. Here a point A is the limit proportionality of the limit up the Hooke's law and beyond, called a proportionality limit. A point B is the elastic limit and which material shows in the elastic behavior, and a point C is the maximum stress we can withstand without breaking, and point D is the breaking point and the material breaks. Okay, this long questions we have done. We will talk inshallah in the next class. Allah Hafiz.